How's it going, everyone? Welcome back to the channel. Today we're going to be talking about the complexities as well as the opportunities when it comes to industrial data. Now, there's going to be a lot of different buzzwords that you'll hear whether you're visiting trade shows or you're reading some of the publications on LinkedIn, or maybe you're following some of the OEMs and or other groups that are spreading this kind of information. And so those are going to be your IoT, Industry 4.0, UNS. And so ultimately my goal here is to explain why it is not as simple as some of these groups make it sound, based on my experience and based on years of trying to pull data in a contextualized fashion from a lot of these end users and ultimately sending that data to either SCADA and MES layers for processing and then decision making. So let's start with the absolute fundamentals. My goal is to make this as simple as possible to understand why are we all involved in manufacturing. Manufacturing is a fairly straightforward process if we want to look at it from a 10,000 standpoint view. So you have a manufacturing facility, right? So I'm going to draw that as a box, and it ultimately is a system. So this is the MFG system, and I'm going to write that in here. And what is a system? A system has a set of inputs and a set of outputs. So in manufacturing, what do you typically have? You have, number one, you have raw materials. So I'm going to obviously oversimplify this a little bit. And you have the output. You have the system that transformed this into finished products. So this is finished products. And don't worry, I'm going to tie this as to how this relates to data, but let me get there. So finished products. And here, the less obvious inputs into the system, you have your labor, right? So this is going to be your labor. You also have rejects from the system, right? So once you run product or you run raw materials on the manufacturing floor, you're going to have some rejects or quality defects. So this is going to be waste. So we're going to have waste as it's an output, but it's not finished product. So we're going to reclassify that depending on your production. That's going to obviously be either recycled, thrown away, or maybe repurposed. Now, where am I going with this? The opportunity for manufacturers is to understand the inputs, their transformation journey, and ultimately how they become finished products. Now, a facility does not run at 100% efficiency. So if you've not been in manufacturing, what ultimately happens is, I don't know, you have 10,000 pounds of raw materials that go in, you have labor that goes in, right? So those are the workers, those are the assets or the machines, right? The electricity that you pay for. You're not going to necessarily get 10,000 pounds of finished product. You're going to get less than that, but you're also going to spend some amount of time creating that product, right? So this could be, and again, I'm using very loose examples just to illustrate a point here, but this transformation can take, for example, 1 week. Right? So efficiency is not only measured by how much finished product is created, it is also measured by how long it took to transform that product, because the faster you can make the product, ultimately the least assets you need to make that transformation. And in tangible terms, that could mean that the manufacturer can purchase 2 lines if they are more efficient, then need 3 lines to meet that demand. Now, where am I going with all of this? There's a lot of different data that can be collected from the plant floor in order to understand this sort of black box of the manufacturing system, in order to make different decisions, whether that's on the technical side or decisions on the business side. And the reason why this becomes complex, as we'll see in just a moment, is that because there are so many intricacies that can be not only captured, but also understood, transformed, but also deduced in very different ways from one side to the other. And unlike many other vendors may seem to suggest, it is not a purely technical problem. There's also human problems, but ultimately the architecture of the facility is going to play a significant role on how the data is extracted, how the data is stored, how the data is processed, and ultimately who gets to make the decision as to how do we use that data for decision making. So let's answer the fundamental question of what is data, where is it being generated, and who's ultimately capturing this data that we all seem to be talking about. On the manufacturing floor, and here I'm going to write a very I guess, basic example, you're going to have different devices. So here's a conveyor belt. There's going to be a couple of rollers. Here I'm going to have a motor. And again, I'm not going to spend a lot of time drawing this. Here you have a motor. Here you have a couple of sensors. You have boxes going through. Again, there could be a lot of details in these drawings, but the goal here is to illustrate a simple principle, right? So you have a couple of sensors. Maybe you have some kind of a pusher that's going to move the box over. In any case, you have automation systems that will be creating data. You also have humans that generate data. So if you have an operator, or if you have maybe a smaller operation, you're going to be doing a lot of manual entry. You're going to open up a spreadsheet. You're going to be typing out what kind of batch you're running, what kind of data the batch is being produced. But you also have that in sophisticated facilities, right? So you're going to take some of the product and you're going to test that in a lab, and the results of those tests are going to dictate whether you're going to keep a certain amount of that product for, let's call in the extreme cases for a recall, or if you're going to let that product through to the end customer. So data can come from different sources, but for this context, we're going to talk about industrial automation data. So here, for example, you have a motor that's going to be three-phase, that's going to go to a VFD. And again, I'm going to save a little bit of details, but here you have a signal, here you have sensors that will send the signal, and here you have sensors that will send the signal. Now, the first layer of your field devices is not going to perform any logic in general. So you need a system that will collect the data from those devices and then be able to make decisions as to what needs to happen in the process. And those are going to be your PLCs, your PACs, your distributed control systems, or DCS. Again, that's a whole other debate and conversation, but for the purposes of this tutorial, mostly you're going to have PLCs, right? And so all of these devices are going to be either inputs or outputs into the PLC in order for the PLC to be as the brain of the operation, in order for it to perform different control system operations. Now, it's important to understand that the goal of the PLC is to perform process-related operations. In the recent years, we've seen a lot of different controllers come out with different features and different software and different ways to organize your applications, and it is possible to write a lot of different software on your PLC to store data, to present data. There's going to be dashboards that come out of the PLC, but the first fundamental function is that you want to be able to control the process which transforms your raw materials into finished goods using the machinery that the PLC controls. Now, taking a step back, taking that higher level approach, your PLC is going to control a machine. Another PLC is going to control another machine or a different area of the plant. So you're going to start creating a line of PLCs and different assets associated with those PLCs. Next, you have what is called HMIs. So here you have an HMI, and again, I'm going to draw a box. What is an HMI? So an HMI is ultimately a screen that allows the operator to view information as to what's happening on the process, but also adjust parameters, view different faults, reset faults, maybe change parameters based on the recipe, and so on and so forth. An HMI is ultimately going to communicate with the PLC. And again, I'm trying to oversimplify this because an HMI can also pull data from the field devices directly. Now, there's going to be many ways to get this done, but ultimately, in a very basic example, your PLC and HMI are interrelated, and the HMI provides control to the data that's coming into the PLC. Now, I want to make a distinction here, right? Because ultimately, we have signals, and we're going to get into that in just a moment, but you have signals here that are coming into the PLC. That is going to be your raw data, and that's a very important concept to understand, because if the PLC is going to combine, let's say, the two signals, or it's going to add a counter, it's going to add a timer, that is no longer raw data from the plant floor. And we'll see why that is important in just a moment. But ultimately, what I want you to understand is that there's going to be other systems connecting to the PLC, and they can either be pulling in the raw data, or they can be pulling in transformed or second-hand data at that point in time. All right, so let's look at the first challenge when it comes to industrial data. And we're going to map this out as best as I can. So ultimately, let's look at a sensor. So a sensor In this case, it's going to be an inductive prox, very simple. This is as basic as you can get on the production floor. So this sensor is going to have a wire that goes into the PLC as we've discussed before. And this is going to be a card. In this case, let's assume that the sensor is digital. So the sensor can either output a 0 or a 1. So a 0 or a 1, a high or a low. And this input card, is going to have one terminal block where this sensor is going to land. There's going to be two wires going to 24 volts and ground. That's not overly important. That's just to power the sensor. Now, how is this signal generated? If something is in front of the sensor, right? So if I have a box in front of the sensor, then the sensor is going to send a 1 or a 0. Again, you can set it to send a 0 when the box is there. You can send it to a 1 when the box is there. That doesn't really matter. But when the box is there, it's going to send a high. When the box is not there, it's going to send a low. So what happens at that point, right? So this input card, let's assume again, it is part of a series of cards, and then it's connected to our PLC. And let's assume that this connection is Ethernet. And there's obviously going to be different parameters. This could be Modbus, Profinet, RS-232 type of signals. It could be just a digital on the PLC rack. So how is the signal ultimately being sent to the PLC matters. Why does that matter? It matters for a couple of reasons. So number one, usually if you look for the data sheets of these sensors, the data sheet is going to indicate how quickly after the box has been detected, the sensor is going to send that signal back to the PLC, right? So what I mean by that is when the box is here, I'm going to have, let's say, a 40 millisecond delay to send that into the I/O card. Then there's going to be a data sheet that tells me that from this point, there's going to be some processing, right? So this data is not going to be immediately sent instantaneously to the PLC. There is some processing time of that card. And again, let's assume that's 40 milliseconds. Again, you can find the exact specifications depending on the vendor. That's going to vary greatly depending on the line of PLCs. Some PLCs from the 60s are going to take a lot longer. Then there's going to be the specification of sending that over Ethernet, and then you're going to get the PLC scan cycle. So what I mean by all of this, or what I'm trying to get at here, is that there's going to be a delay between the detection of the physical object and when the PLC is able to make a decision, right? What to do with this signal once the data is there. Now, this was the very simple case. This problem is amplified when it comes to analog signals. So again, let's take another example. So we have this large vessel here. Again, obviously not drawn to scale, but we have a sensor that's going to be sitting all the way at the top and looking at the level of this tank here that it is measuring, right? So the tank can have, let's call it, this is 0% full and this is 100% full. And so this sensor is going to come into the analog card, right? So this is going to be in a completely different card, analog and digital signals. We get into that topic maybe in a separate video, but it's going to be processed by a different card and then sent to the PLC. And so here you're going to have an analog to digital conversion before you can get that data. Now, where am I going with all of this? Ultimately, what I want to draw, I guess, an example of is what data do you truly care about and which system cares about that data differently, right? So once the data is in, the PLC needs to make a decision. Then that data is going to be passed on to an HMI, right? So here we're going to have, again, an HMI to PLC connection. Next, you're going to have a SCADA system. So I'm going to say SCADA, which supervisory control and data acquisition. Again, there's going to be some debates whether SCADA is part of HMI or SCADA is part of, or an HMI is part of SCADA. But ultimately, what I want you to take away is that a SCADA is going to control multiple machines, right? So here, I'm going to draw this line. It's controlling this machine, that it's controlling this machine 2. It's going to control machine 3. Etc., etc. But ultimately, it supervises, it also gives you some information as to how the system has been doing in the past, and that's going to be your SCADA platform. Next, you have the MES, or Manufacturing Execution System, And so here, once again, depending on your architecture, you could have a direct connection from PLC to MES, or you can be pulling from SCADA, which then has an aggregate of different signals. And so what I want to get at is, where do you care about this information, right? So depending on the nature of that information, you're going to care at different levels. And so I want to make an analogy, so I'm going to erase this board and we'll come back to this in just a second, but let's look at a real life example of why do you care about different types of data. And so the analogy that I want to make today is that of an automobile and the response to an air leak. So ultimately, a lot of us are working from home, but some of us do have to go into work. And so I'm going to drive this nice car. It could be probably nicer. There's somebody sitting here and is driving to work, right? And so what happens on the road, or what happens in the system of the car, is that you're ultimately monitoring a bunch of sensors. So you have a pressure sensor, right? So this is going to be P1. Here you have a P2, and each tire has a pressure monitor. Again, we can debate whether that's in modern cars or previous cars, but you have tire pressure sensors. Once you encounter a puncture, so the puncture in your tire is going to start deflating. Once it drops below a certain pressure level, you're going to have a warning. So here I have an alarm, low pressure. And so why is this important? This is important because who is that alarm destined for? So number one, it is an alarm upon which the driver needs to immediately act and pull over to make sure that there's no issue with the tire, which ultimately there is. So hopefully they pull over within the next couple of, I want to say, seconds, or hopefully minutes if they have a small enough leak, and they're able to change that tire. Does this alarm need to send a real-time response or notification back to any other parties? Maybe your parents, your spouse, your friends? And the opinion is that it does not, right? They don't need to be notified of all your alarms of all their friends at any given time. Why do they not need to be notified? Because they will not make a decision that will impact any of the system functionality, right? So the same thing can be said about manufacturing. So when you're starting to send alarms and sending statuses into a central repository that will not be acted upon up until maybe a later date, maybe someone will check the tank level at some point in time and then decide that they needed to be doing something differently. But the thing is that you need to understand that although this notifies the driver within a matter of seconds, it does not need to notify other parties within that same time frame. So what that ultimately means is that you can have a system where the pressure monitor, the alarm system, and the driver that makes the decision is going to be real time, or again, we'll explore what real time truly means. And for any other parties, that operator or that driver is then going to pick up the phone and, hey, you know what, I'm late to work. I'm not going to be able to make it for another 20 minutes because someone's going to tow my car or help me replace with the spare. So what I'm trying to illustrate here is, in manufacturing, it is very much the same scenario where you have parties arguing for real-time data. The question that you as the leader or as the manager or even as an engineer should be asking is, why do we need that data in real time? Because ultimately you will be paying higher fees for having real-time data you don't necessarily need. So let's go back to manufacturing and look at a couple of examples. All right, so back to a very simple batching system. I have two different tanks. One of them is nearly full that needs to be transferred to the second tank, right? So this is tank number one. This is tank number two. I am collecting both levels as well as the actuation of the pump via the PLC. So this pump has a wire, this sensor here has a wire, and then there's going to be a sensor from tank number two into my PLC. So which sensors or which data do we need at a real-time data, and where do we need it versus where we might wait a little bit? So let's look at an example where we have the operator here. So this is the operator that's looking over the system and sees that the tank one is approaching the completed or the full level, upon which he needs to transfer that liquid, that batch, into tank number 2. So obviously, for as long as the batch doesn't get transferred to tank number 2, assuming that there's no wastage due to it being still, there's a lost time of production here, right? So as soon as the batch is reaching 100%, any time that it spends within that tank is a lost opportunity for that manufacturer to start a second batch, right? Because as soon as that tank empties out, we can now start putting in the ingredients for the next run. So the time the operator takes to react from that information is directly impactful for this production, which means that we need to know this information in real time. Now, what does real time mean? We didn't necessarily have that conversation either, but in case of a broken tire, you should be getting that information within a couple of seconds, where in reality the electronics will pick that up in milliseconds. There's going to be some, again, maybe some digital to analog or analog to digital conversion. Then there's going to be a couple of milliseconds or microseconds depending on the onboard computer of the vehicle, but ultimately within a few seconds it's reasonable for you to get that notification. So similarly here, you're going to have this PLC and HMI combo. The PLC is going to read that level. Once it reaches that 100%, or even maybe at 99, it could send off the alarm. So here I'm going to have an alarm appear, which is going to be in real time, right? So this alarm is going to cause the operator to go look at the system. Hey, we can move this. He's going to verify that this tank is empty. He's going to move this batch into the second process by clicking a button on the HMI and ultimately actuating the pump that's going to be between those two tanks. Now, where do these SCADA and MES layers come in? Now, I've explained that SCADA is going to look at maybe a little bit more than just a single PLC or just a single area. You're going to see, for example, I have these two tanks. Now I have a duplicate of 5 of these systems, or maybe I have a warehouse, or maybe I have a palletizing operation, or another system that's going to be controlled by additional PLCs, additional distributed control systems. So the SCADA is also going to be important, right? So if I'm the operator of whatever process fills into this, right? So this is process B that feeds into this first tank, then I need to look at a couple of different areas, how things are operating, so that I could tell the PLC from this process to start the batch once this operator empties out tank number 1. But anyways, the point is that at the SCADA layer, you don't need as much of a, or you can have a time delay between the response, because here when I start emptying this tank, I now know that I can, within, let's say, 10 minutes, I can start putting in the second batch or the next batch into that first tank of this specific area. So there could be some delay as to how often the PLC will update the SCADA system. Now, on the MES side, and this is where a lot of my disagreements maybe with some of the other individuals come in, the truth is, very few individuals at the, let's call it, supervisor, manager, and decision level positions are going to need this data to that granularity when it comes to sensor level data on a real-time basis, right? What do I mean by that? You definitely want to understand how different batches go through the process, but you are ultimately concerned about the delay, right? So I've explained this a little bit. There's going to be a time delay between this is your tank full and operator start batch, start transfer, right? And again, I'm using this as an example. There's going to be dozens of different use cases of these different nuances, but you care about the delay from when the operator is notified that the tank 1 is ready to be put into tank number 2, and the time that they actually start that transfer, right? Because that is a direct opportunity to save money for your facility. Now, do you need that information in real time? Do you want to be woken up at 2 a.m. to tell you, instead of, let's say, this can be 5 minutes, but in this scenario, it was 8 minutes, right? So this definitely did not meet the spec for whatever reason, and we can get into that conversation, but this did not meet the spec. At 2 a.m. you receive either an SMS or a notification from your MES system that tells you there was a problem with the batch. No, you don't necessarily need that information, right? So Here, what we're trying to illustrate is that the MES systems are not going to necessarily be susceptible to collecting this data in real-time basis simply because it is not needed. It is needed more for decision making. It is needed more for longer term decisions than what at the PLC, HMI, and SCADA layers. And again, that is just one example. Let's talk about another nuance when it comes to these industrial data signals. And this is not understood until you actually spend a lot of time on the floor and you try to pass this data along, and then you start getting a lot of these questions as to why there's so much traffic on the network, why are we passing this data in real time? So let's look again at a tank that we've looked at in the past. And so tanks are very common, like vessels for storage in food facilities as well as beverage. So here you have a tank, and here you have a sensor that is reading the level of the tank, and you have a sensor usually confirming that it's at 0% or it's empty, and you have a sensor that confirms it's at 100%. Again, it's just fail safes. But ultimately, what does this mean? It means that right now you have two cards. Again, we'll assume that this one is going to be analog, and we'll assume that these are going to be digital, right? And so you go through a project where you want to extract that data. So this is going to be in your remote I/O rack, and this is going to be in the PLC that's going to be driving the logic for this specific process. Now, where does the complexity lie? I've explained a little bit what it takes to send the signals, right? And there's going to be some delay from when the physical presence of the product is detected to when it is actually received by the PLC. But let's assume that I want to get the tank level from the sensor into my MES system, right? And someone suggests we're going to have this distributed architecture that's going to be in real time collecting that data, and it's going to always make it available so you can go back and look at it at any point in time, right? The first question I would always ask is like, why would you care about the level of the tank but at any point in time? But the ultimate question is the resolution of that data, right? So here what happens is I have a sensor that measures an analog level. What does that actually mean? It measures from, usually it's going to be set at different set points, but it's ultimately going to measure like 0, like I said, percent is going to be set to 100%. And so it's going to measure 0 to 100% full. Now, that is not the entire picture of the story, right? Because ultimately the sensor is going to report deviations, right? Because the liquid here is not perfect. The sensor is not perfect. The environment is not perfect. There's going to be some, how would I say it, blemishes in that data and in that reporting. So let's assume that the liquid is completely empty. You're going to get this reading, 00034, right? Obviously, that is extremely low. So this is going to be reading 1. Reading 2 is going to be 0.00036. The tank is still empty, but you get my point. You're starting to get these different readings, 0.013, right? And so what I'm trying to illustrate here is that ultimately this is the empty state. And you could argue that I could, in my PLC, set that if it's below, let's say 1, then the tank is technically empty. Now, however, if you try to send the raw data every time on change to my MES system, you could see how you're going to have a problem, right? Like similarly, when the tank is, if I'm the operator and I look inside the tank and I see that it's 30% full, the reality is that the sensor is going to send a signal that's 30.06384, 30.08378. So what can you do, right? So the first step that you ultimately understand that if you start sending that, so this is, imagine this is my MES, you're starting to send that as soon as it changes. And in this case, we define change as different signals. Then you're going to start stressing the system with packets at the millisecond or microsecond level. That would be even worse. Obviously here you have a switch. Why is that a problem? It is a problem, like I said, because you don't necessarily, number one, need that data, but you're also sending at a resolution that doesn't make sense, that simply creates traffic on your network. So where do you draw the line? Again, this goes back to the point of what are you going to do with this data, right? So if I know that the tank is at 30% and it goes to 31%, what am I going to do with that data? Chances are not a whole lot, right? If it goes to 32%, chances are not a whole lot. So how do we solve this problem? At this point, we can truncate everything besides the decimal, right? So ultimately here we're sending 30, when it goes to 32, when it goes to 33, all the way to 100. Now, the problem that you can maybe predict is the fact that this is a tank measuring or a tank like distance sensor application, but in other scenarios when you have the same analog sensor, that is going to actually matter. You're going to need that decimal point up to a certain degree to send that to your MES system. And so what happens in manufacturing and in industrial data is that it is not that easy to draw this line. And where the line is going to ultimately fall is between sending too much data, thus essentially you getting charged for storing that data, for processing that data, depending on who the vendors are, or you will send too little data, right? So for example, if I only capture this data every 10 minutes and my tank fills out in 5 minutes, then you're going to lose resolution, and thus you will not be able to understand the process that you have in front of you, and you're not going to be able to make decisions that make an impact on the process and thus solve any of your problems. So the challenge here is that you need an expert, or usually a team of experts, that understand not only the process but also understand the signals, the electronics, and the data layer to be able to make some of the decisions on the architecture, but also understand the nuances of sending too much or too little information. All right, so here's the next challenge when it comes to industrial automation and manufacturing, and that is custom systems, right? What do I mean by custom systems? If I'm looking to start a brewery, right? If I'm looking to brew my own, whether that's beer or liquor, then the process is fairly understood. We already have books and manuals on how to conduct the process of brewing, and so for the most part you're going to use off-the-shelf equipment. Now that is not the entire story, because if I'm going to use off-the-shelf equipment for any of my process, that doesn't necessarily mean that the system is not going to be custom, right? So what I'm going to do is, let's say I'm going to rent a large space, and here I'm going to have system 1, system 2, and this is going to be packaging 1, packaging 2, and we're going to say packaging 3, and this is system 3, right? So this is the brewing process, and then the packaging process, whether that's, in this case, let's say I'm going to pick a can line, so can line, and here I'm brewing beer, so brewing beer. So I have some kind of a fermentation tank. I'm going to have some kind of tank to add the hops, the flavors, to boil the water and the brew, and then I'm going to have the liquor built in to bacteria, and then I'm going to create a system that feeds this into the can line. Now again, there's going to be multiple vendors of can lines, there's going to be multiple vendors of brewing systems, there's going to be multiple layouts that I can do this with, right? And so I could have a pipe to tank 3, I can have a pipe to tank 2. Here on the can line, maybe I have a second case packer for maybe boxes that I want to do of different variations. Here I'm going to remerge this into the palletizer. So this is P2B. I want to add a labeler that's going to print outside of the can. So long story short is that no system, or I don't want to say that no system looks exactly the same, but it's very difficult to take a data solution that's been put on one manufacturing site and then take that whole architecture and put it on a different site, because the systems are simply so different, right? You also have the factor of a integrator who's going to come in and do that job, right? If I fly out and I'm going to program a facility out of Georgia, and then one of my colleagues out of Alberta flies out and does a facility in Louisiana, the programming style is going to be different. And of course, there's going to be some standards, there's going to be packaging standards, there's going to be batching standards. But I can guarantee you that no system programmed by two different individuals is going to be programmed in the same fashion, even though the system is the exact same. So what I'm trying to get to here is the fact that the industrial data is extremely complex to extract in a contextualized way is because of custom systems. And I can tell you from personal experience, and even when you're manufacturing the exact same product at 4 different sites, simply because those systems have been started up in different years, because they had different integrators come in, because they have different layouts, because they have different conveying systems between them, are not going to be identical. So what that ultimately means is that you will have to spend some time, effort, and ultimately money on someone who can come in and assess the system before they can understand how to extract the data, what the architecture looks like, what kind of hardware and software is needed. Look, in conclusion, I believe that there's a ton of opportunity when it comes to industrial data, but I also believe that there are many challenges that a lot of people are not necessarily discussing. I think that data context is extremely difficult to infer, but also to understand. And I think it takes somebody boots on the floor that understands the system, that spends enough time learning the systems, but also understands the nuances of these electrical and hardware and software components to be able to tie that pertinently together. I think there's a lot of opportunity to create architectures that allow you to select how do you actually pull the data out, how do you put certain limits on data, because again, as I've illustrated with a couple of examples, you can spend a lot of money on signals you cannot make any decisions with on either, I want to say, like sides of the complexity circle, whether that's you don't have enough data because you simply are collecting too slowly, or you have too much data, thus you're paying for a lot of ingestion, processing, storage. And the last but not least, the custom nature of the system. So the custom nature of the systems makes it so that it is a fairly significant investment from a dollar value for manufacturing leaders to make in order to understand what is going on the production floor, and it is not easily replicable from one system to the other. And if anyone's trying to convince you that you can simply take a software package and apply it to your system without having any audit or knowledge or understanding or deep level. And again, we'll talk about audits, we'll talk about how to actually understand some of these systems from my experience, but I simply think that they're misleading you and are going to charge you a lot of money for something you're not going to be able to have a positive impact on your business with. In any case, if you have any questions on this topic or any other topics that we've covered before or will be covering, if you have some suggestions on conversations when it comes to manufacturing, industrial automation, data, some of the platforms that we see across different layers from field devices all the way to ERP, don't hesitate to leave me a comment and or get in touch with me on LinkedIn.